just here, I'm gonna start the first part of chapter 27. And in chapter 27, we are talking about wave optics. Just a reminder that chapter 4 is gonna be, exam 4 is gonna be based on chapter 25, 26, and 27. Okay, now here in this picture, you're gonna see a laser beam that is emitted, and it is like a very convergent beam of light, and is gonna be traveling in straight line. And we're gonna find that the laser beam, when it's gonna go through a grid of vertical slits, will produce what is called an interference pattern like this. Okay, here this is okay, showing you like fringes of light separated by dark spots. Now this happens for all the waves, especially light wave, and we call it interference. And that happens when two light waves occupy the same space at the same time. Then they're gonna occupy the same space, and therefore what we are going to do, something we call it superposition, means I'm gonna add. Then you're gonna see here, if I have two waves, one of them is 2 centimeters at its peak and the other one is 2 centimeters at its peak, they are going to form what is called constructive interference, which means reinforcement. And what you are going to see is a double amplitude. We call this bright fringe. Then if I'm talking about light waves, this is going to be a very bright area. On the other hand, if I'm going to have these two waves, the blue one and the red one, they're going to be interfering in this way where the crest is going to meet with the trough. We're going to have this, okay, destructive interference. This is the peak, we call it, or crest. And this one, it is called the trough, and they're gonna cancel each other, and we call this destructive interference. They're gonna yield a dark fringe. Okay, now this can be actually explained. We can explain now interference. In terms of what is called the Huygens principle, where we are going to have that like what is called wavefront, and each point in the wavefront is going to create a new like let's say, I would say sub fronts. And then when I connect the points on these, they're going to form a new wavefront, and then these are going to be sources, and therefore we're going to see that this is how really waves are really propagate. And this is what was brought by Huygens to explain really how really light is propagating. One more thing also here, it is we're talking about when the wave that we are representing by these parallel lights, this is, by the way, this is, we call it beam, and that one we call it wave front. Then when that light is gonna be striking an opening, what's gonna happen is gonna be bending about the edges. This is, we call it diffraction. And the amount of bending is more extreme, or is going to be clearer when we have the opening smaller and smaller. Okay, then if this actually opening is very close to the wavelength of the light, then we're going to have, we're going to have it the clearest, like you can see here. This is called diffraction. Then usually light, when it's gonna have an opening, it's gonna behave with diffraction and interference together. There is a very important and famous experiment in physics called Young's double slit, and they're Young, a scientist who was using a light and shining the light into two slits so that he will create the same coherent light through these two slits, and that they're gonna interfere. And here we're gonna have a screen where we can see bright and dark fringes. Now this one here is assumed to have without diffraction, okay? That is gonna be the interference, where it's gonna be equal intensity for all. And we're gonna know that based on the path taken by the light, we are going to have either constructive interference or destructive interference. For the constructive interference, we're gonna have two waves where they have a path difference of lambda, or 2 lambdas or 3 lambdas, and therefore one of them might come like this and the other one is gonna come, okay, and let me continue with the red, okay, and then the dark, the black here is gonna start. Then here we're gonna have that maybe lambda is the difference between them, maybe 2 lambdas. And then the condition for constructive interference is going to be d sine theta equals m lambda. That m is going to take values from 0, plus or minus 1, plus or minus 2, plus or minus 3. Now for m equals 0, this is the case where we're going to have the central image, the central fringe, and that is one is going to be always the bright fringe. With this destructive, one of them is going to be delaying, half of the lambda, and therefore we're going to have d sine theta will equal m plus 1/2 times lambda, and that is going to be m equals 0 plus or minus 1 plus or minus 2.